Okay, second lesson for today. Again, you should be watching this on the Ed Puzzle site and not on YouTube. All right, perpendicular bisector. When we say that you have a perpendicular bisector for a segment, okay, and it has to be a segment because we're going to cut it in half, bisector, it means that that line is both perpendicular to the segment and it bisects it. Pretty easy. Equidistant just means equal distant. So if a point is equidistant from something, it's the same distance from both of them. Okay, so pretty easy vocabulary today. All right, what the perpendicular bisector theorem tells us is that in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So looking at our picture here, we can see that CP is the perpendicular bisector. It's marked perpendicular, and AP and BP are congruent, so it is the bisector also. So that means that the endpoints A and B are both equidistant from any point. So CA would be equal to CB. Those two lengths would be equidistant. And that's our perpendicular bisector theorem. Okay, so example 1. This is a pretty simple example, but it tells us that AC is the perpendicular bisector. So any point on AC is going to be equidistant from the endpoints, B and D. So AD will be equal to AB. Go ahead and substitute those in and solve for x. The hard part is done, so make your substitution. AD is 4x units long, and AB is 7x minus 6. They didn't give you really much room to solve for x, so go ahead and do that over here. Solve for x, then tell me how long AD is. Okay, so solving for x, subtract 7x from both sides, and we get negative 3x equals negative 6. Divide both sides by negative 3, and we end up with x equals positive 2. Watch your signs here. So AD is 4x units long. That is 4 times 2. That is 8. And again, we can check our work here. Figure out how long AB is. 7 times 2 minus 6. 14 minus 6 is 8. It works. So, how long is AD? AD is 8 units long. All right, the converse of the perpendicular bisector theorem says that in a plane, if a point is equidistant from the endpoints of a segment, so D is the same distance from A and B, then it is on the perpendicular bisector of the segment. So if DA and DB are equal, then D lies on the perpendicular bisector of AB. So here's an example that uses that. What segment lengths in the diagram are equal? So for part A, we know that KN is a perpendicular bisector. Okay, so KN bisects JL, so we know that JN is equal to NL. All right. Because K is the perpendicular bisector of JL, we know that JK is going to be equal to KL. Theorem 5.2 was the mid-segment theorem. I'm sorry, the perpendicular bisector theorem. And the diagram shows us that JM and ML are both 13, so we know that those are the same length too. So now the second question, is M on KN? Well, because MJ and ML are equal, M is equidistant from J and L. So, by the converse of the perpendicular bisector theorem, we know that M is on the perpendicular bisector JL, which is KN. So the answer is yes, reason, converse of the perpendicular bisector theorem. All right, so here's some for you. When you enter these in, go ahead and enter them as, I'll go ahead and do the first one. Since you don't have a congruent symbol, enter them in as GF and HF. So there's two others. Go ahead and tell me what they are. All right, so hopefully you got GJ, or segment GJ is congruent to segment HJ, and segment GK is congruent to segment HK. All right, so next, go ahead and do checkpoint number 2. Find the length of GH. All right, so hopefully everyone got 4. Here's how that works. So we just said that GK and HK are the same length. So 2x equals x plus 1. Subtract x from both sides and we get x equals 1. If I plug that back in, GK is 2 times 1, or 2 units long. HK is 1 plus 1, or 2 units long. Now, pay attention to the question. The question was, how long is GH? So if GK is 2 units long and KH is 2 units long, GH would be 4. So that is our answer, 4 units long. All right, that's it. And hope you guys enjoyed this video. Hope you guys like the new edpuzzle.com site, and I will see you tomorrow.